So yesterday, if you were absent yesterday, we defined perimeter as the boundary of a particular shape. So if you have a triangle, the perimeter would just be the distance around the shape, where my finger's at. That's just the perimeter. Of any shape, it's just a distance. Area, on the other hand, was two-dimensional flat space inside the shape. Remember the distance between A and B, between any 2 points in space, distance is one-dimensional. Pure distance, pure length is one-dimensional. Length and width, if you have a flat surface, a flat shape, like a cartoon or something that's not 3D, you're thinking of two dimensions, just length and width. And then 3D, we got length, width, and then height, or sometimes called depth. 3 dimensions. Right now, we're hanging out in 2 dimensions. What the heck does area mean? Well, it's just all the 2-dimensional space inside a flat surface. So, that note guide I gave you, actually not the note guide, the reference sheet, has some area formulas for different shapes, common shapes. Notice the top 5 shapes, we're going to be hanging out there this week. The bottom shapes are going to be next week, because that's 3 dimensions. Let me get this first example up here. Here we are. So, that reference sheet I gave you, the top 5 shapes, triangle, rectangle, trapezoid, parallelogram, and circle, we're going to be hanging out here this week. Next week is 3D time. This week is 2 dimensions, next week is 3 dimensions. So, notice on the formulas here, there's no formulas for perimeter. There's only formulas for area on the top 5 shapes. Everyone with me? So everyone has this out. Notice the top 5 shapes, there's only area formulas, not perimeters. Because perimeter, all perimeter means is add up all the sides. There's no need to memorize a formula for that. As opposed to area, we have formulas. It's a little more complex. On your notes from yesterday now. Different one? My bad. What's the matter with me? Forgive me. Coffee has kicked in, you're right. Go to write example 1 on your notes from yesterday. Remember we defined 2 words. Actually, wait. Before that, my bad. Before that, sorry. Let's define height. Let's define height before we get into that example. What the heck does height mean? Here we go. What is this concept of height in geometry? Let's define it here. Here we are. I'm going to write the word height. This is the 3rd word. Yesterday was perimeter and area. This is the 3rd word of our notes. I'm going to write the word height. A synonym is altitude. I'm going to write the perpendicular distance between the base and the opposite vertex. The perpendicular distance between the base and the opposite vertex. Now, when I say perpendicular, that's just a fancy word for 90 degrees. So I'm going to put a parenthesis with 90 degrees on it if you don't know what perpendicular means. And go ahead and draw 3 triangles exactly the way they're shaped here on your notes underneath that. The 3 triangles, make them like you see them here, as close as possible. The height. So, this idea of height, the height of an object is the perpendicular 90 degrees. That's what perpendicular means, the 90-degree distance between the base and the opposite vertex. So look at the first triangle you drew. Here's your base. Go ahead and put a line here. Just make it a little thicker to highlight it and put B for base. Opposite vertexes means that the vertex just means it's a fancy word for a corner of the triangle, a corner of a shape. So if this is the base, the opposite vertex is right here. Now the distance between the base and the opposite vertex, Rodriguez, is going to be 90-degree distance. So I'm going to put a little dotted line here coming down, and let's make this 90 degrees. That little box means a 90-degree right angle. So this would be my height, H. Well, look at the second triangle now that you drew. The second triangle actually has a 90-degree angle in it. So in this case, the base of this triangle would be the bottom side, and the height would actually be the side of the triangle itself. Compare that case with the first case. The first case, the height is actually some imaginary line inside the triangle that's actually not a side of the triangle, yet it's still the height of the triangle. Case 2, the height is actually the side of the triangle because this is perpendicular. There's a 90-degree angle in the triangle. Case 3, we call this an obtuse triangle. We have an obtuse angle here. If I extend a line down dotted that extends with the base, here's my base right here. The base would be from here to here. But notice the 90 degree will be outside the triangle itself, and the height would actually be outside the triangle itself. Notice 3 cases. Height is inside triangle. Case 2, height is the side of the triangle. Case 3, height is outside the triangle. We have to know how to distinguish and differentiate between base and height if I throw a triangle at you of any kind. It can get kind of confusing. Let's try example 1 now, with that in mind. You have your formula sheet I just gave you. Is that it there? Example 4. So you have your formula sheet. Let's do example 1 for today. Here we are. So go ahead and put example 1. I put find A and P. A is per area, P is for perimeter. Let's find area and perimeter. Go and draw this. Just going to do 3 simple examples. So again, this is all on yesterday's notes. This is a continuation of yesterday's notes. That note guide I gave you is just a reference sheet. You can't breathe. Forget the area and perimeter. Let's go to the nurse. Perimeter is like a cakewalk. That video yesterday showed you perimeter just means the outside of a shape. Remember that guy walking? So imagine a guy walking around this triangle. He's going to walk 6 what? Does it say feet, inches? Right, so we'll just use a generic term, perfect, units, which means just whatever they're measuring it in. It's 6 whatever they're measuring it in, so we'll just say units. So the person will walk 6 units, 5 units, and 5 units. That makes 16. So go ahead and put P equals 16 units. So if they don't specify, if you run into a problem where it's not specified what kind of units, you just write the word units. Try not earphones off. All right, area time. Look at your reference sheet. We actually wrote it yesterday on yesterday's notes also. What is the area formula more of a triangle?
1/2 base times height.
Perfectly said. 1/2 base times the height. We know what a base is now. We just went over that. We know what the height is now. It's the perpendicular distance from the base to the opposite vertex. All we got to do is plug and chug and we're done. It's ridiculous. You should be laughing. Area is 1/2. Ramos, what's my base? Yep. Bottom side, 6. So 1/2 times 6. Ayala, what would be my height? Exactly. We're looking for perpendicularity. 90 degrees, right here. Look at there it is. Base, opposite vertex. What's the distance, perpendicular distance? It's going to be 4. That goes for the height. We're rocking and rolling. Question so far before I just do the multiplication now. Area then is 1/2 times 6 is the same as 6 divided by 2, which would be 3. 3 times 4. Area is 12. What? Chickens, horses, or termites? What kind of units? Aardvarks. I love it. Square units. Remember the squares that fit inside now. It's two-dimensional space. Area means two-dimensional space. You can't measure two-dimensional space other than square tiles. If you can think of another way to measure two-dimensional space, let me know. And I'll give you an A+ in my class. There's no other way to measure two-dimensional space than square units. Question number 1. Let's do a trapezoid. Write example 2 now. Let's do some traps. Draw the trapezoid. If you look at the area reference sheet on a trapezoid, it's probably the funkiest formula out of all the shapes, the trapezoid formula. Before we get into the formula though, what the heck does these little arrows mean? What are these trying to communicate, these arrows? Anybody know? It's weird. Go ahead. Okay, go ahead. Parallel. Don't put parallel. So these arrows indicate parallel. That means if I extended this side forever, imagine if you were able to do that, and the top side forever, those two sides would go on infinitely without ever touching. It's like parallel freeways or parallel streets. What's some parallel streets here in Pomona? Holt and Mission. Holt and Mission are parallel streets. Mills and East End, they're parallel, right? So a trapezoid then is a 4-sided figure with one pair of parallel sides. These two are definitely not parallel. Look at these two sides. They're going to end up connecting up there somewhere if you were to extend them. So it's a special kind of 4-sided figure with one pair of parallel sides. Now, the formula on your sheet is real funky. It says the area, it's not 1/2 base times height. It's actually 1/2 the quantity of both bases, B1 plus B2. Now, what are the bases? B sub 1 and B sub 2, these are subscripts, these little numbers. They refer to both bases, which are actually the sides that are parallel. So this would be one base, and this would be the other base. So if you're not going to remember that, I would write it down on your notes. This is a base, and so is this top side. The two sides that are parallel are the bases. Before I answer that, applying a little bit of logic, what would you say? What would be your gut feeling? Would it matter? Would I put base 1 and base 2 in there? If I'm adding two quantities, does it matter which comes first? No, because if you add any two quantities, logically, it doesn't matter which comes first. You're still going to add them, so it doesn't matter. By the way, I forgot, this is all times the height. It's a funky formula. It's right there on your reference sheet, by the way. Trapezoid. So let's see how much two-dimensional space this trapezoid takes up. How much two-dimensional space? Let's see. Start plugging and chugging. Area then is going to be 1/2. Yanez, can you give me one base here? Nice. Pinello, can you give me the other base? Excuse me? No worries. Acevedo, can you give me the other base? That's one base. What's the other one? 17. Nice. So notice both bases go in the parentheses, B sub 1, B sub 2. I'm looking for the height now. Ramos, hit it. Perpendicularity, there's your 90 degrees, remember? You're looking for perpendicularity. When you're looking for the height, perpendicular distance from the base to the opposite corner, opposite vertex, there it is. It's going to be 14. I'll replace H with 14. We're rocking and rolling. The rest is just, please excuse my dear Aunt Susie. Parentheses first. Let's do it. 1/2. So bad with mental math. 26 times 14. 1/2 times 26 is the same as 26 divided by 2. So it'll be 13 times 14. Anybody got that for me? 82? Chickens, horses, or termites more? No aardvarks, by the way. Square. Square what? We're done, hon. That's how much two-dimensional space it takes up. Questions? Cool. Last one. Example 3. We'll do circles tomorrow. We're going to do circles, parallelograms tomorrow. I don't give you guys nightmares. It's a very special number involved with circles. I'm going to finish this problem up here. The area is 1/2 base 1 plus base 2 times the height. Both bases would be the parallel sides. The height is the perpendicular distance. Here's your perpendicularity, the 90 degrees, from one base to the opposite vertex. So it's going to be 10. So I got 15. Both bases would be 15 and 7. The height would be 10. So it's 1/2 times 22 times 10. 1/2 times 22 is 11. 11 times 10 is going to be 110 square units in this case.